Okay, now let's talk about how energy is related through balanced equations. Let's first define what that really means. I'm going to talk to you first about exothermic and endothermic reactions. So exothermic reactions is when heat is released into the atmosphere. So this is when something gets hot. And that happens through certain numbers of bonds breaking and reforming, okay? This is a very classic type of graph that you typically see within chemistry, minus those two terms right there. So on this y-axis, what we're seeing is energy increasing. And here on the reaction axis, that's just showing you, hey, this thing progresses this way. So you can consider this time with no set hashtag or hash marks, if you will. The energy of the reactants are higher than that of the products. So that means that heat has been released in this process, right? So I'm going to go and skip down for just a second to what the heat of reaction is. The heat of reaction is delta H. So the heat of the products, which is a low number, minus that of reactants, which is a higher number. This should be a negative delta H if you've got an exothermic reaction. So that's why it's negative delta H. That's not necessarily, though, what you see in a balanced equation. In the balanced equation, it says these two things come together, and as one of the products gives you this energy that's released as well. So you've got to be able to take that and turn it into the proper sign. On the other hand, an endothermic reaction, the products have a higher energy level than that of the reactants. Okay, what this little bump means, by the way, is that, hey, it takes energy to get there. Just like it might take you more energy to be at school than it did to be at home, but you still have to get dressed and get ready and that type of thing, and it's a little bit more chill to sit in a classroom than it is to, have to drive through traffic and stuff. In this case, though, when we write the balanced equation, the energy goes into the system. So if you want to think of this, when these things mix together, gives you C. It's kind of like when you mix those cold packs together for knee injuries or things like that. It gets cold because it's taking energy from the outside system. And that's what exactly is happening with an endothermic reaction. So in this case, delta H is going to have a positive value. Okay. Now we can use this in math just like we can use our other types of things from balanced equations. Because what you can simply say is that so many moles of A are going to give you that many kilojoules of energy. So we use this the same way that we used everything else that we've done. It's just a different number value when you look at the molar equivalents, okay? So if we looked at A, we could say 1 mole of A is 500 kilojoules, or 500 kilojoules is equal to 1 mole of A. Okay. So if you have 5 grams of A, how many kilojoules of energy will be produced is a very common type of question. In this case, what you do is you go from 5 grams of A, use the molar mass, and determine how many moles of A you have, and then use this guy to figure out how many kilojoules of energy you would have. Okay. These types of examples are all through the internet. There's lots of different examples, so go ahead and practice those as well. Okay. Thank you very much.